Hello students, today let us learn a method of solving ordinary differential equations, that is second order differential equations. So let us learn the Milne's predictor corrector method to solve second order differential equations. So let us consider an example. Apply Milne's predictor corrector method to compute y of 1.4 given that 2 times d2y by dx square plus 4x plus y dash and the following set of initial values. So this set of initial values is given to us along with the differential equation. Now we need to apply Milne's predictor corrector method to compute this second order differential equation uh, at yx equal to 1.4. Now what we do is reduce this second order differential equation to a ordinary differential equation. So for that we need to substitute y dash equal to z. So we will be substituting y dash is equal to z in the given differential equation. Now if you differentiate this y dash once again, we get y double dash which is equal to z dash. Now y double dash is nothing but our given differential equation. So from the given differential equation, y double dash is equal to 2 times x, that is bring dividing the whole equation by 2 which is there on the LHS. So you'll be getting 2 times x plus y dash by 2. So the second order differential equation d2y by dx square is 2 times x plus y dash by 2, but y dash is z. So it is z by 2, and we are denoting this d2y by dx curve as z dash because y dash is z, y double dash becomes z dash. Thus we have reduced it to two simultaneous ordinary differential equation. One is y dash equal to z, the other one is z dash equal to 2x plus z by 2. Now we will go for this table once again. Write the given set of values of the tables, that is with names for them, naming them. So x is there, y and z are there. We have written them as it is. Now with these set of values, but denoting them by particular names. Here x is there, x and the set of values of x are denoted by x naught, x1, x2 and x3. Correspondingly, we have the set of values of y, y naught, y1, y2 and y3. Now, the next value given in our example is z. So, z is nothing but our y dash. So, y dash equal to z, and we will denote them by y naught dash or z naught. Correspondingly, again y1 dash or z1, y2 dash or z2, and y3 dash or z3. Now, these all values are given to us. Now, we need to calculate one more value along with these, that is, we need z dash. Now z dash from this equation it is 2x plus z by 2. So that is written here. Z dash is 2x plus z by 2. Now write this equation in your calculator. Then go on giving the corresponding values of x and z. Now if you give x naught and z naught, we will get z naught dash. So if we put x naught as 1 here, that is x as 1, then z naught is 2, that is z is 2, then we'll get 2 plus 1, that is 3. This is denoted by z naught dash. Similarly, substituting x1 and z1 in this equation, we will get z1 dash. Again, similarly, we'll get z2 dash and z3 dash. Now, once we calculate all this, we are done with the table. Now we go for the Milne's predictor formulae. Now the formula goes as y naught plus 4h by 3 2 times y1 dash minus y2 dash plus 2 y3 dash. Substitute the values correctly. So y naught means it is here y naught equal to 2. So substitute y naught as 2. 4 times h. Now h, you know already, it is the difference between any two consecutive values of x. So x1 minus x naught, if we do 1.1 minus 1, that gives us the value of h, and here it is 0.1 divided by 3 we have, then 2 times y1 dash. So y1 dash it is here. So That is why we need to note the values so that correctly we can substitute in the formula. Y1 dash, it is here 2.3178. We'll be substituting that. Then minus, it is y2 dash. Y2 dash value, it is here 2.6725. Put it here. Then plus 2 times we have y3 dash. 2 times y3 dash, it is 3.0675. 657, sorry. Now calculate this, then we get the value of the predicted value of y4, that is 3.0793. Now we are done with Milne's predictor formula for y4. Now we need to go for z4 predicted value. So z is nothing but y dash. Z, we have denoted y dash as z. So that y dash value we need to calculate. So z4 raised to p, the formula goes similar to that as y4 raised to p. Instead of y, we will be writing z. So we have z naught plus 4h by 3 into 2z1 dash minus z2 dash plus 2z3 dash. So z naught value here we have 2, then 4h by 3, same as in the previous formula. Then 2 times z1 dash, it is here z1 dash. Then the next we have z2 dash, and then we have z3 dash. All are available in the table. Now substitute them in the formula, calculate it, then we get the value of z4 raised to p as 3.4996. Now z4 is nothing but y dash. So sorry, y4 dash. Z is nothing but y dash. So Z4 is nothing but y4 dash. Now once we get this values of Z4P, then we have to go for Milne's character formulae. Now the formula goes as y2 plus h by 3, y2 dash plus 4y3 dash plus y4 dash. Now here we'll substitute the value of y2 from the table. It is 2.4649. Then EHS point 1 divided by 3, we have y2 dash. It is here y2 dash. Then we have y3 dash from the table. Now y4 dash, that is not there in the table, but we know already that y4 dash is nothing but z4, and the value we have obtained is 3.4996. So substitute that value, simplify, we get the value of first corrected value of y4 as 3.0794. Now the predicted value of y4 we had obtained was 3.0793, and now the corrected value we have obtained for y4 is 3.0794. You can see that the values won't match in the fourth decimal place. Hence, we need to apply corrector once again. And anyhow, in the question also it is mentioned that we need to apply corrector twice. Now, before going for correct second time applying the corrector formula, we need to go for z4 first corrected value. So as we did the z4 predicted value, similar to that, z4 first corrected is same as y4 first corrected value. In place of y, we will be writing again z. So the formula is z2 plus h by 3, z2 dash instead of y2 dash, then 4 times it is z3 dash, then plus it is z4 dash. Now substitute the values. Z2 we have it from the table here. Then Z2 dash and Z3 dash we have from the last row here. Z2 dash and Z3 dash. But we don't have the value of Z4 dash. Now that we need to calculate. Now how to calculate Z4 dash? Z dash is nothing but 2x plus Z by 2. We already know it. Now Z4 dash we want. So it's written here z4 dash is 2 times x4 plus z4 by 2. Substitute the value of x4, x3 it is 1.3, that means x4 becomes 1.4, and z4 value, it is nothing but the predicted value of z4 that we have just now obtained. Substituting the value of x4 and z4, we get z4 dash as 4.5498. Now that value of z4 dash is substituted, other values are substituted from the table. Now calculating, we get the value of z4c1 as 3.4997, and again it is nothing but our y4 dash. Now we go for applying the Milne's character formula once again. So y4 c2. Just we, instead of writing c there, corrector formula, c1 for first correction, c2 for the second correction. This formula goes as before only, same it is. Only thing that changes is y4 dash, because whatever value of y4 dash, new y4 dash that we have got, that will be substituted in this. Okay, that's the only change that we are making. Now, substituting the value of new y4 dash here, we get the value. I think I have to put it here as 7, that is 3.4997 y4 dash value. Now put this value, new value of y4 dash, simplify it, the answer we get is 3.0794. Now y4 first corrected value was also 3.0794. The second corrected value is also 3.0794. Hence, the two values match, and we can stop the iteration and say that the value of y at x equal to 1.4 is 3.0794. However, if the values won't match and if nothing is mentioned in the question, then we need to carry on the iteration once again. That is, if the first corrected and the second corrected value of y4 does not match, then again we have to calculate z4 c2 and then go for y4 c3. Then if they match, we can stop the iteration there, or else the procedure will be continued. Now, since in the question it is mentioned apply corrector twice, we can stop it here and write the answer as whatever the value we have obtained. Now, this is the Milne's method to solve the second order differential equations. Thank you.